morning, students. I welcome you all in this lecture of the beta and gamma function. Today I am going to discuss the Dirichlet formula for evaluation of the triple integral, and then I will prove the Liouvilles formula, which is your just extension of the Dirichlet formula. And these two formulae are very important for the evaluation of the triple integral. So before proving the Dirichlet formula, let us prove the lemma, which is basically for the double integral. So we have the lemma: if B is a region your x greater than equal to 0, y greater than equal to 0, and your x plus y less than equal to h, then the value of this double integral x power n minus 1 y power m minus 1 into dx dy is equal to s power n plus n into gamma l into gamma m upon gamma l plus m. So solution. It is given that if D is the region x greater than equal to 0, y greater than equal to 0, and x plus y less than equal to h, then we have to show that this double integral is equal to s power n plus n into gamma l into gamma m upon gamma l plus m. Now if your h is equal to 1, then we will have just gamma l into gamma m upon gamma l plus m. So solution, because your x plus y is less than equal to h, so let us divide by h. So we have this equation, and if you assume this x upon h as cap u, then we will have u plus b is less than equal to 1. So we have u equal to x upon h and v equal to y upon h. So from here our x equal to uh and your y equal to vh. So here we have dx equal to u h du and y equal to dy equal to h dv. So let us put these two values in this left hand side. So therefore this domain D will give you, now this will be your, now here we have u plus v less than equal to 1, so that means I have transformed my x axis y axis into u v axis, or I have substituted the value of u and v. So here we have the condition u plus v less than equal to 1, so that means if this is your u axis and this is your v axis, so we have u plus v less than equal to 1. So that means this is your region, and again here we have v equal to 0, and so this point is your 0 comma 1, and here we have 1 comma 0, and if you take the vertical strip, then here you can see that your v will be from 0 to 1 minus u. So this integral can be written as, let us take the value of u as from 0 to 1. So your u is from 0 to 1, and the value of v will be from 0 to 1 minus u. Take this limit of u from 0 to 1, then for the limit of v, we will take the lower limit and upper limit of this vertical strip. So here we will have v equal to 0, and here if you take any point of this line, then we will have v equal to 1 minus u, and put the value of x, which is your uh, y is equal to vh, and then your dx is equal to s du, and your dy is h du. So this is equal to h power n minus 1 and h power n minus 1, that means h power n plus m minus 2, and here we have h square. So this will be your h power n plus n, and then we have the integral u equal to 0 to 1, v equal to 0 to 1 minus u, then here we will have u power n minus 1 and v power n minus 1 into du dt. So this is your u power n minus 1, v power n minus 1 into du into dv. Now this is your limit of v. So let us integrate first with respect to v. Here we have the limit of v in terms of u, that means limits of v are variable. So first integrate with respect to v. So this will be your h power l plus m, then we have u equal to 0 to 1. And now the integration of v power m minus 1 with respect to v will be v power m upon m. And the limits will be from v equal to 0 to 1 minus u into du. So we have h power l plus m, then u will be 0 to 1. Now this is your, if you put, and here we have u power l minus 1. Now if you put v as 1 minus u, then this will be 1 minus u power m. And for the lower limit we have 0 into du. So this is equal to h power l plus m divided by m, then integral 0 to 1, u power l minus 1 into 1 minus u power m plus 1 minus 1 du. Now this is your definition of beta function, x power l minus 1 into 1 minus x power m minus 1. So this is equal to beta l comma m plus 1. And here we have this beta l comma m as gamma l into gamma m upon gamma l plus m plus 1. Now your gamma m plus 1 is m gamma m, so this m will get cancelled. So we have h power l plus m gamma l into gamma m upon gamma l plus m plus 1. So this is your solution for this double integral. Here we will have gamma l plus m plus 1. Here we will have gamma l plus m plus 1. So this is the value of this double integral. And if your h is 1, then this left hand side will be equal to gamma l into gamma m upon gamma l plus m plus 1. Now let us extend this double integral for the triple integral, and for that we have the Dirichlet theorem. So your Dirichlet integral let D is the domain for which your x is positive, y is positive, z is positive, and your x plus y plus z is less than equal to 1, then the value of this triple integral is equal to gamma l, gamma n, gamma n upon gamma l plus m plus n plus 1. So if D is the domain for which your x is positive, y is positive, z is positive, and your x plus y plus z is less than equal to 1, then we have to show that the value of this triple integral is equal to this 1. Now solution, here as our x plus y plus z is less than equal to 1, as your x plus y plus z is less than equal to 1, so we can write y plus z as less than equal to 1 minus x. So if you assume 1 minus x as h, then we have y plus z less than equal to h. Now the value of this triple integral will be, now this triple integral can be written as let us put the limit, as we have x plus y plus z less than equal to 1, so the limits of x will be from 0 to 1, limits of y will be from 0 to 1 minus x, and limit of z will be from 0 to 1 minus x minus y. So here we will have x from 0 to 1, y from 0 to 1 minus x, and z from 1 minus x minus y. Now let us put 1 minus x at h. So this will be your h, and this will be your h minus y, and here we will have x power n minus 1, y power n minus 1, z power n minus 1, dx, dy, dz, where your x plus y plus z is less than equal to 1. So from here your y plus z will be less than equal to 1 minus x. So this is your h. So your y plus z is less than equal to h. So now using the previous lemma, which was your, now we can write this one as integral 0 to 1, then integral 0 to h, now 0 to h minus 1, h minus y power n minus 1, z power n minus 1, dy dz, then in the outside, at outside we will have x power n minus 1 into dx. Now using the previous lemma, which was your double integral y power m minus 1, z power n minus 1, dy dz equal to gamma L into gamma m upon gamma n plus m plus 1 multiplied by the h into the sum of the powers. So using the previous lemma, this will be equal to, now if you use the previous lemma, then this will be equal to h power your m plus n, then we will have gamma m into gamma n upon gamma m plus n, and here we have x power l minus 1 into dx. So this is because of the previous lemma. Now let us put the value of h as 1 minus x. So put h equal to 1 minus x. So if you put h equal to 1 minus x, then this is equal to integral 0 to 1. Your h is 1 minus x, and take the constant on outside. So we have gamma m on gamma l plus m plus 1. Now in the bracket we will have integral 0 to 1. H is your 1 minus x. Then in the power we have m plus n, and here we have x power n minus 1 into dx. Now this can be written as gamma l into gamma m upon gamma n plus m plus 1. Then we have integral 0 to 1, x power n minus 1, 1 minus x power n plus n minus plus 1 minus 1 into dx. Now this is your again definition of the beta function, x power l minus 1 into 1 minus x power m minus 1. So this is equal to gamma l into gamma m upon gamma l plus n plus 1 into beta l comma m plus n plus 1, and this is equal to gamma l into gamma m upon gamma l plus m plus 1 into beta. The value of beta gamma m into gamma n is equal to gamma l into gamma n plus 1 divided by gamma l plus n plus n plus 1. Now this term is cancelled. So this is equal to, here we have a mistake, this was your gamma m into gamma n. So here we have gamma n. So this is equal to gamma l into gamma m into gamma n divided by gamma l plus m plus n plus 1. So this is the value of this triple integral, and this triple integral is known as the Dirichlet integral. Now let us prove the Liouvilles theorem, which is your just the extension of the Dirichlet theorem or Dirichlet integral. So we have Liouvilles integral, which is your basically the extension of Dirichlet integral. So the statement is, let D is the domain for which we have your all x, y, z are positive, such that your x, y, z lies between h1 and h2. Then the triple integral d of f of x plus y plus z into x power n minus 1, y power n minus 1, z power n minus 1, dx dy dz. Now this is equal to gamma L into gamma m into gamma n upon gamma L plus m plus n. Then the integral from h1 to h2 fu into u power n plus m plus n minus 1 into d. So this is the value of this triple integral, and the basic difference between this formula and the Dirichlet one and the Dirichlet formula is that in case of Dirichlet formula we do not have any function of x plus y plus z, but here we have some function of x plus y plus z in this integral. So the value of this triple integral, for which we have f of x plus y plus z multiplied with this x power l minus 1, y power m minus 1, z power n minus 1, the value of this triple integral is equal to gamma l, gamma m, gamma n upon gamma l plus m plus n. In case of Dirichlet theorem, we have here gamma n plus 1, but here we have gamma l plus m plus n. Then the limits of the sum x plus y plus z was from h1 to h2, then we will have fu into u power l plus m plus n minus 1 into d. So let us prove this Liouvilles integral with the help of the Dirichlet integral. So proof by Dirichlet integral, we have this triple integral equal to, the value of this triple integral was, now let us assume we have this triple integral equal to u power l plus m plus n into gamma l, gamma m, gamma n upon gamma l plus m plus n whenever your x plus y plus z is less than equal to u. So if your x plus y plus z is less than equal to u, then the value of this triple integral is equal to this one. And let's assume this triple integral as I. So therefore, if your x plus y plus z is less than equal to u, then we have this I equal to u power l plus m plus n into gamma l, gamma n, gamma n divided by gamma l plus m plus n plus 1. Then we have plus 1. So here we have plus 1. This was proved in our Dirichlet integral, and if you put u equal to 1, the rest part was the Dirichlet integral. Now this is the value of I for your x plus y plus z less than equal to u. Now if your x plus y plus z is less than equal to u plus delta u, then your I will be u power u plus delta u power l plus m plus n, then gamma l, gamma m, gamma n upon gamma l plus m plus n plus 1. So the value of this triple integral is equal to this one. Now the value of the integral extended. Now the value of the integral which is extended for all such values of the positive values of the x, y and z. Now the value of the integral extended for all such positive values of the variable, for such positive values of the variables as make the sum of variables lying between u and u plus delta u is given by, now here we have extended your I for u plus delta u, so the value of the integral extended for all such positive values of the variables as make the sum of variable to lie between u and u plus delta u is given by the L gamma n upon gamma L plus m plus n plus 1 common, and in the bracket we have u plus delta u power L plus m plus n minus u power L plus m plus n. So we have these two terms. Now again, let us take this u power L plus m plus n common. So if you take u common, then this is equal to, so if you take u common, then we have u power L plus m plus n common, so we have gamma L, gamma m into gamma n divided by gamma L plus m plus n plus 1, then we will have u power m L plus m plus n, then now in the bracket we will have 1 plus delta u upon u power L plus m plus n minus 1. Now if you use the binomial series 1 plus x power n, then for the small values of delta u, we can neglect the higher terms. That means we can neglect the order 2 terms or higher terms. So we have this integral equal to gamma L, gamma m, gamma n upon gamma L plus m plus n, then u power L plus m plus n. Now just expand this term with the help of the binomial series. So this will be 1 plus x power n. So we will have 1 plus nx. So this will be L plus m plus n into delta u upon u. Then we will have the square of this delta u, and the square of this delta u will be again very small. So we have minus minus. Then finally we will have minus 1. So we have minus minus, and then finally last one will be minus 1. So this minus 1 and plus 1 get cancelled. So now I am neglecting the higher order terms. So on neglecting the higher order term, because your delta is very small increment, so if you neglect the higher order terms, then this integral is equal to gamma L into gamma m into gamma n upon gamma L plus m plus n. Now here we will have, this is again plus 1 plus 1. Now this u will go in the numerator, so this will be your u power L plus m plus n minus 1. Then we will have multiplied by L plus m plus n, then your delta u. Now again, this is your gamma, say this is your gamma n plus 1. So gamma n plus 1 is n gamma n. So your L plus m plus n will get cancelled. So this integral is equal to, so finally this integral is equal to gamma L, gamma m, gamma n upon gamma L plus m plus n, then multiplied by u power L plus m plus n minus 1 into your delta u. So this is equal to now when our variables, when x plus y plus z lie between u plus delta u, u and u plus delta u, when your x plus y plus z lies between u and u plus delta u, then the value of f of x plus y plus z can only differ by f of small quantity of order same as of delta u. Now when your x plus y plus z lies between u and u plus delta u, then the value of this f of x plus y plus z can only differ by your f of u by a small quantity delta of order same as of delta u. So hence the part of the integral, your triple integral f of x plus y plus z, x power n minus 1, y power n minus 1, z power n minus 1 dx dy dz. Please note that this was the value of this triple integral extended for u plus delta u. So the value extended for u plus delta u will give you the value of the part of some part of the integral as your gamma L, gamma M, gamma N upon gamma L plus M plus N. Then we will have f of u and then u power n plus m plus n minus 1 and multiplied by delta u, where the variables lies between u and u plus delta u, where the sum of variables lies between u and u plus delta u. Now this was the part of the integral for small delta u. Now the whole integral is given by, hence the whole integral is equal to triple integral f of x plus y plus z, x power n minus 1, y power n minus 1, z power n minus 1 dx dy dz. Now this will be equal to gamma L, gamma M, gamma N upon gamma L plus M plus N. Now for the whole integral, your x plus y plus z was between h1 to h2. So we have h1 to h2, fu, u power L plus M plus N minus 1, then du, not delta u. Now this is your du, and this is your proof of the Liouvilles theorem, which is the extension of the Dirichlet integral. Now question, find the volume of x upon a power 2 by 3 plus y upon b power 2 by 3 for z upon c power 2 by 3 equal to 1. So just find out the volume of this solid. So solution, in the volume of this solid will be basically, now if your, let us assume x greater than equal to 0, y greater than equal to 0, z greater than equal to 0, then the volume of the solid will be basically equal to A times, I am just taking the first positive octane. So as I am talking about the positive octane, so the volume of this solid will be 8 times of this portion dx dy dz. And for this, where your V is the region for which your x is positive, y is positive, and your z is positive. So the volume of the solid is equal to A times dx dy dz, and where my B is the region for which your x is positive, y is positive, and z is positive. Now let us evaluate this triple integral with the help of the Dirichlet integral. Now let us assume x upon a power 2 by 3 as u and y upon b power 2 by 3 equal to v and z upon c power 2 by 3 equal to w. So from here we have x equal to u a into u power 3 by 2. Your y will be v into v power 3 by 2 and your z will be c into w power 3 by 2. So your dx is 3a by 2. Then we will have u power 3 by 2 minus 1 into du. Your dy will be 3b by 2. Then we will have b power 3 by 2 minus 1 into dv. And your dz will be 3c by 2 w power 3 by 2 minus 1 dw. So your volume integral is equal to, put the value of dx dy dz, so we have 3, 3, 3. So this will be your 27 abc upon 8. Then we will have u power 3 by 2 minus 1, v power 3 by 2 minus 1, w power 3 by 2 minus 1 into du, dv, dw. So this is equal to 27 abc upon 8 into the value of the triple integral, for which we have u power 3 by 2 minus 1, v power 3 by 2 minus 1 and w power 3 by 2 minus 1 into du, dv, dw. Now with the help of Dirichlet integral, this is your gamma L into gamma M into gamma N divided by gamma L plus M plus N plus 1. So this is equal to 27 ABC upon 8 multiplied by gamma 3 by 2 into gamma 3 by 2 into gamma 3 by 2 divided by gamma L plus M plus N plus 1. So we will have 3 by 2 plus 3 by 2 plus 3 by 2. That means 9 by 2 plus 1. So this is your 11 by 2 and this can be written as 27 ABC upon 8 multiplied by, now this is your gamma 3 by 2 which is your half gamma half. So we can write it as half gamma half. Half gamma half is root pi. Again the second term will be half root pi and the last one is gamma 3 by 2. And the denominator we have 9 by 2 into 7 by 2 into 5 by 2 into 3 by 2 into gamma 3 by 2. Now this gamma 3 by 2 will get cancelled. So here we have 2 to the 4 to the 8. So this 8 will get cancelled. 9 and then 9 into 3, that means this 27 will get cancelled. So we have 2 here. So this 2 will go in the numerator and will get cancelled with this one. So we have 1.70 pi ABC. So the value of this triple integral is pi ABC upon 70. Hence volume of solid is equal to A times pi ABC upon 70. So this will be your 4 upon 35 pi ABC. So this is the volume of the solid.